G'day, in this physics skills video, we're going to be doing a little bit of a review on trigonometry. Now, trigonometry is all sorts of geometrical applications that we have with triangles specifically, and that can be quite important in the world of physics because a lot of the time when we start looking at motion in a plane and beyond, we begin to work in triangles. We might start drawing up a diagram and say, hey, wait a minute, when we put all these vectors and motions together, it makes a triangle. Being able to use trigonometry rules and applying them can allow us to find values that we otherwise would not know without this trigonometric application. So we're going to do a little bit of review on all of the rules that you probably learnt in year 9 or 10. There might be a couple that you may not have been introduced to yet, or you may not be that familiar with. So yeah, we're going to introduce those, and that's going to give us the tools to then be able to begin to apply them in context when we're completing physics practice questions. So our first one here is Pythagorean theorem. It exists when we're looking at a right angled triangle that's involving all three side lengths, so A, B, and C, which is always our hypotenuse. The relationship between our sides for a right angled triangle is that A squared plus B squared is equal to C squared. What that means is if we know two of our side lengths, we can always solve for the other one. It only works with a right angled triangle though. Our next rule is all about SOHCAHTOA. Again, only for right angled trigonometry though. So if we have an angle, let's call it theta, which is a Greek letter. Doesn't matter where you put theta, works all the same. But let's say we put theta down in the bottom right hand corner. We then have O, A, and H. O is for opposite. H is for hypotenuse. And A is for adjacent or next to. So in this case, when we're looking at using our SOHCAHTOA, if we know where our angle is that we have, we can always put down label the opposite side as O, label the adjacent side as A, and label the hypotenuse, the longer side, as H. From there, you can either be using your sine, cos, or tan functions along with two of the side lengths to either be calculating for an unknown angle or using the size of an angle and one known length to be able to calculate an unknown length. This next one might be a little less familiar to it. It's called sine rule or the law of sines. And these trigonometry rules are really good for when we have a non-right angled triangle. And in physics, a lot of the time, that's what we're working with. Effectively, you can label a triangle by its angles and its sides. If we put capitals for our angles A, B, and C, what we always say is then that the opposite side to each angle is the lowercase version. So if I have capital A, the opposite side is A, capital C, the opposite side is little c, and if I have capital B, the opposite side is little b. Then for all of your angle and opposite side combinations, you can take the sine of the angle and divide by the length of the side, and the ratio is always going to be equal to all the other ratios of angles and side lengths. So you may see an equation just with sine A, sine B, but technically you can also have sine C and side length C in the equation as well, but when you're applying the sine rule, you don't use all three at the same time. But yeah, it doesn't matter which combination you're looking at. You always have your angle, you always have your opposite side. And if you take the sine of the angle and divide it by the side length, it's going to be equal to all of those other ratios for all of the other combinations that you have too. So this is really useful when maybe you know like two sides and one angle, you can find a missing angle. It can be useful too when you have two angles and you know one of the sides for one of the opposite pairs, but not for the other. And it means that you can then calculate for those unknown parts. We can also use cos rule, the law of cosines. It's a little bit different. This one involves all three sides and one angle instead of two angles and two sides. So we use the same kind of notation where our little letters represent our side lengths and our big capitals represent our angles. So in this case, we have c squared is equal to a squared plus b squared minus 2ab times cos c. So for example, if you knew a, b, and c, you could put all those numbers in and solve for capital C, the angle for this one here. Similarly, if you knew C, the angle, and knew 2 of the side lengths but not another one, you could solve for either A, B, or C, those side lengths, and that would work too. If you forgot how to solve for angles using trig, I'm just going to do a couple of really quick practice questions just to show you what that looks like. So for example, if I have a triangle here that is a 3, 4, 5 right angle triangle, let's keep it simple, but I didn't know what our angle theta here was. I could use our SOHCAHTOA rule to calculate for theta, but that will require me to use an inverse trig function. So let's say that I use sine. So sine theta, based on our little mnemonic so, means that sine theta is equal to opposite over hypotenuse. I can put my opposite side in 3, my hypotenuse 5, and that is equal to, again, sine theta. Now, if I just do 3 divided by 5, that's not going to tell me what the angle theta is. I need to move this sine function over to the other side, just like we would for any other algebraic solution. Just like we would for any other algebraic problem. Now, to do that, what we need to do is apply the inverse operation. Effectively, what that looks like is we end up with theta on one side. We then put sine to the -1 on the other, and we apply it to everything that was on the right-hand side, in this case, 3 over 5. When that goes into your calculator, you should roughly get something along the lines of 37 degrees. Now, it doesn't matter whether you're using right angled trig or you're using non-right angled trig, the way that we calculate for the angle and make the angle the subject works the same in any case. But we'll do one using the sine rule as an example this time. So in this case, I'm going to have 2 side lengths. It's going to be 3 and 4, just to keep it simple. And the angle here we're going to say is 30 degrees. Now with this information and the sine rule, we can calculate for the unknown angle on the right, which is opposite to our side length of 3. Now using the sine rule, we can have our sine 30 divided by the opposite side length, which is 4, and say that that is equal to sine of theta and its opposite side length, which is 3. Now rearranging for theta, first thing that I'm going to do is multiply by 3 on both sides. So 3 times sine 30 over 4 is equal to sine theta. And then to solve for theta, I'm going to put that by itself on one side and say that that's equal to sine inverse, or sine to the -1, of everything that was on the left-hand side previously. So that's going to be 3 times sine 30 over 4. And the number that we get there is approximately 22 degrees. Now, hopefully our trig skills and our ability to use our algebra to solve is going to be pretty straightforward. If that's the case, then this table is probably going to be most important or valuable to you. The question should always be, when do I use which formula? And the answer depends on whether or not you're working with a right angle triangle or a non-right angle triangle, and what values you know and which one you're trying to find. So this table sort of breaks all of that up. So for example, for Pythagorean theorem, only works with a right angled triangle, and you can only be using that when we're looking at 3 side lengths. In other words, 2 known, 1 unknown. For SOHCAHTOA and TOA, again, right angled triangles, you want to be using that when you have 1 angle and 2 side lengths, one of those values being unknown. For sine rule and cos rule, we only work with non-right angled triangles. Technically, you can use it for a right angled triangle, but it's not particularly necessary. You can just use SOHCAHTOA and TOA. That is a much easier formula to work with. Technically you can, but there's not really much point. For sine rule, again, we're looking at instances where we have 2 pairs of angles and opposite sides. So either out of those pairs, one of the angles is unknown or one of the opposite sides is unknown. For cos rule, non-right angled triangles, we have 3 side lengths and 1 angle where either one of the sides or that angle is unknown. Now, this is a lot of math to sort of keep up in your head. We don't find any of this information in the data sheet. However, my advice is practice, 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 practice. If you are doing lots of practice problems that involve the use of vectors and trigonometry in your physics calculations, these kinds of techniques are just going to be something that's in your toolkit that allows you to solve really flexibly and effectively when coming across all sorts of different physics problems. So keep practicing. We'll keep pulling up examples in class that require us to apply trigonometry, and we'll build up our skills throughout the coming 2 years.